The comprehensive Protaper universal system comes complete with instruments for simple, fast, efficient, and safe root canal treatment. The rotary Protaper files enable high-quality canal preparation in a very short time. Once direct access to the canal has been created, the opening is filled with hypochlorite. Then the canal is explored with a 010 K file or a 013 Celsius Profinder file. The file is worked gently down the canal. It's stopped when resistance is encountered. Throughout the procedure, hypochlorite is used to irrigate extensively after each instrument is used. The identical process is used with a 015 file or a 013 Celsius Profinder. The distance that the file has been inserted into the canal without using force is measured. This measurement is copied onto the first instrument, S1. To avoid perforations, the S1 must be brushed in the opposite direction to the furcation. If necessary, the auxiliary SX serves to eliminate the triangle of dentine and create direct access to the canals. The 015 K hand file or 013 Celsius Profinder is used to establish the working length, in addition to an X-ray and an apex locator like Propex. This measurement is copied onto the S1, which is matched to the working length by brushing away from the furcation danger. A 010 K file can be used as a patency file between each instrument change. The working length is copied onto the S2. Brushing movements are used on the S2 until the working length is reached. The same working length is applied to the F1. As with all finishing instruments, there's no brushing, simply in and out movements. As soon as the working length is reached, the instrument is immediately withdrawn. A 020K file is introduced up to the working length to gauge the apical diameter of the canal. When snug, the apical diameter is 20/100ths of a millimeter. If the file is still loose, the F2 is used. Here the diameter is 0.20. For the obturation, a gutta percha F1 of the working length is appropriate, or an F1 Protaper obturator. Another example is this wider canal. The F1 finishing file is inserted to the working length. The 020K file is used at the working length to check the apical diameter. The apical diameter is larger than 20/100ths of a millimeter, so the file does not fit snugly. The F2 finishing file is applied at the working length. To measure the apex, a 025K file is used passively at the working length. Even with the 025K file, the fit is not close enough, so the F3 is tried. The same routine that was followed for the F2 is appropriate for the F3. Since the 030K file is not a close fit, an F4 finishing file is used at the working length. Irrigation. Next, the apical diameter is gauged with a 040K file. Now the fit is snug along the working length. The 040K file corresponds to the apical diameter. Depending on the chosen obturation method, an F4 gutta percha cone or a Protaper F4 obturator is selected. The Protaper for hand-use files have the same design as mechanical instruments. They're used in difficult procedures, such as severe apical curvatures. The operational steps are identical to the mechanical system. A 010K file or a 013 Celsius Profinder file is inserted passively into the canal as far as possible. An alternative is a 015K file or a 017 Celsius Profinder. In either case, insertion is without force. Irrigation. The insertion length of this file is copied onto the manual S1 Protaper. The manual S1 is turned clockwise and anti-clockwise until resistance is encountered. If necessary, the instruments are cleaned before they're used again. Irrigation between instrument use is copious. A 015K file or a 017 Celsius file is chosen to determine the working length using an X-ray and a Propex apex locator. This length is copied onto the S1. The S1 Protaper for hand use is introduced up to the working length, using the same clockwise and anti-clockwise movements as before. This step is simplified by using a lubricant such as Glide. Irrigation. The working length is copied onto the S2 manual file. The S2 is inserted to the complete length of the canal using the same movements. If resistance is met, the instrument is withdrawn and cleaned, and the site is irrigated. If necessary, this step is repeated. Once the working length is reached with the S2 Protaper, the F1 finishing file is inserted for the entire canal length. Between each instrument change, irrigation is necessary. The apical diameter is determined using a 020K file. If it's a close fit, the diameter is 20 hundredths of a millimeter. If not, then a Protaper for hand-use file of a larger diameter is necessary. In this example, an F1 gutta-percha cone is chosen for obturation. D1 to D3 Protaper files to remove filling material allow simple and efficient retreatment for gutta-percha fillings, thermofill obturators, and zinc oxide eugenol paste fillings. To soften the paste fillings, it's advisable to use a solvent like Dentsply Myofer DMS4. Retreatment is done in two phases. These three mechanical files, D1 to D3, are used to remove the filling material. Then Protaper universal mechanical files are required to shape the canal. The D1 file is the choice for removing the filling material in the coronal part of the canal. The filing movement is in and out to a maximum of 2 to 3 millimeters, if necessary, with brushing motions. The brushing technique is clearly shown in the second canal. Extensive irrigation is needed between instrument changes. The D2 retreatment file is used in the same way, but only in the middle third of the canal. The D3 file goes deeper into the canal without forcing it. When finishing the reopening phase, a K-file with an X-ray and an apex locator, such as a Propex, helps to determine the working length. From now on, all Protaper universal rotary instruments are used at the working length. The canal is now shaped by following the Protaper basic sequence. The S1 file is used first to the working length. The brushing movement can be seen. The S2 file also is used at working length. So is the F1 finishing file, which is worked in and out, but with no brushing. The apical diameter now can be measured using the 020K file. If the fit is snug, the diameter is 20/100ths of a millimeter. If it's loose, then the F2 file is selected. To gauge the apical diameter, a 025K file is tried. If that doesn't work, then an F3 file is next. This case requires a 030K file to find the apical diameter. Then the shaping phase is finished. The same method is employed for the other canals. After irrigation, the canals are dried with Protaper paper points. Gutta-percha cones or Protaper obturators fill the canals. Protaper obturators provide fast, simple, and completely warm three-dimensional fillings. The obturators are stripped so that they can be used as apical gauges to measure the apical diameter. The diameter of the selected Protaper obturator matches the diameter of the last finishing file used at working length. Protaper paper points are ideal for drying the canals. The obturators are decontaminated in a bath of hypochlorite. Once dried and measured against the working length, the obturator is placed in a thermoprep oven. A thin film of top seal, or AH+ sealer, is applied to the coronal part of the canal with a straight probe or a paper point. The obturator is removed from the oven. Then it's slowly and firmly inserted to the working length. With light pressure, it's held in place for a few seconds. Leftover gutta-percha is condensed using a manual plugger. The plastic carrier is cut with a thermocut burr mounted on a turbine. Water spray is avoided. A transparent resin block helps to show the basic sequence of shaping a canal.